All right, today what we're going to do is we're going to prove the Pythagorean theorem. That's what our standard wants us to do. So everything is going to go back to the first part of your notes, which has the two-column proof with the statements and reasons. So every time in the video, when you see the two-column proof, just keep adding your statements and reasons to the first part of your notes. All right, today what we want to do is we want to prove the Pythagorean theorem, which says, given that you have a right triangle, the sum of the squares of the legs, and remember legs are the sides that form the right angle, so A and B would be legs, is equal to the square of the hypotenuse. And remember that the hypotenuse is always going to be across from your right angle, so C would be my hypotenuse. So what are we given? We are given a right triangle, and I'm abbreviating here, and we want to prove that the sum of the squares of the legs, so that's if I square A and B and add them, because that's what sum means, A squared plus B squared, it is equal to the square of the hypotenuse. The hypotenuse is C, so I say equals C squared. And that is the Pythagorean theorem. So I go to my two-column proof, and I say, statement 1, I have a right triangle. How do I know I have a right triangle? Because it is given. That's what we start with. You always start with the given. Okay? Let's go see what it has to do next. Next, it wants us to draw a perpendicular line from the right angle to the hypotenuse as shown in the figure. Now remember, a perpendicular line is a line that forms a 90-degree angle. We want to start at the right angle. We start here and we draw down. We want it to be perpendicular, so it's got to have a right angle to the hypotenuse, which we said C. Now, how many triangles are in the figure above? Well, I see the large right triangle, which is the one we originally started with. That's my large one, which I would draw just like it is. That's my large right triangle. I see a medium-sized right triangle, which would be on the right side. There's my medium-sized right triangle. And finally, I see my small right triangle, which is on the left side. So here's my small right triangle. So how many triangles? 3. Now, what did I do to get the 3 triangles? Let's go back to our two-column proof. To get the 2 triangles, I drew a perpendicular line. So that would be statement 2, because that's the second thing we did. Why can we draw a perpendicular line? Because you can construct anything you want to, so the reason is going to be a construction. So we've got a right triangle, we've drawn a perpendicular line, so we make 3 right triangles in the picture. What do we need to do next? All right, next, let's identify them. So we've got our large triangle, and I'm going to label my parts A, B, C, and D. Those are all my points. And they want us to draw the small right triangle. Now remember, the small right triangle is on the left, so here's my small right triangle. And I copied it over here. This is my small right triangle. And then I want to compare that to the largest triangle. So if I compare that to the largest triangle, I'm going to go all the way around the outside. So here's my large right triangle. Remember your right angles here. Notice that angle B is both in the yellow triangle and the blue triangle. So that would be this angle and this angle. And both triangles have a right triangle. So these triangles are going to be similar by angle. So I can go to my proof and I can name the 2 right triangles. It might help if we put letters here. So let's put A, B, and C in the small one. And then A's on top, B's on the left, and D's on the right. So if we name the small right triangle, I could call it ABC. I'm going to put that in my proof. So I'm going to say triangle ABC is similar to, and let's go back and look at the picture. If we start at A, we need to start at D because A and D are corresponding. If I go from A to B, I need to go from D to B. So I would say D, B, A. So triangle D, B, A. And we know those are similar by the angle-angle theorem because we identified the two angles that were similar. Let's go to the next part. All right, next they want us to construct the medium triangle and the large triangle. So let's compare those. Highlight the medium. Here's my medium triangle. If I label my parts, I have A up here, B, C, and D. So in my medium one, I have A, C, and D. If I want to look at my large triangle, because I want to compare my large one, here's my large triangle and outline it. So that would give me A, B, and D. Now notice that both the yellow triangle and the blue triangle both contain angle D, so that would be congruent to itself. And also the large right triangle has a right angle at A, the medium one has a right angle at C. So I can name these two congruent triangles. So if I name the large triangle, I could call it A, B, D. So let's go back to our first slide and let's add our next statement. So statement 4 would be triangle ABD is similar to, let's go back to our picture. If I start at A, that's the right angle. I got to start at C. I went from A to B, so I got to go from C to A. So I would say CAD. And again, that's by the angle-angle theorem. So now I know that my two triangles or my triangles are similar in the picture. Now we're going to use what we know about similar triangles. If we compare the small triangle and the large triangle, as we've already done, let's make a comparison of the short legs, which in the small triangle, the short leg would be X, and in the large triangle, the shortest leg would be A. So I compared it X over A. That's my ratio. And then I want to compare that to the hypotenuse. I want to say my hypotenuse for my small triangle is A. My hypotenuse for my large triangle is B. I'm sorry, it's not B. My hypotenuse is C. So I said A over C. The same thing if I compare my medium-sized triangle and my large triangle. Here's my large and my medium. All right. If I compare the longest legs here, in this case the longest legs are B and Y. So I said Y over B. I put the medium size on top and the large one on bottom. And I want to compare the hypotenuse to those. The hypotenuse of the large one is C, and the hypotenuse to the medium one's B. So again, I start with the medium, B over C. And as proportions, I can always cross multiply. So that's how I got A squared equals XC. B squared equals YC, which is what I got here. Now let's add our information to our proof. So the first thing we want to do is we want to talk about the proportions. So let's put this proportion and this proportion into the next statement of my proof. So I would say statement 5, which I wrote down, X over A equals A over C. So I would say X over A equals A over C. And on the other one, comparing, I said Y over B equals B over C. So I can put that Y over B equals B over C. And I know that's true because they are proportional sides in similar triangles, so that would be my reason. Corresponding sides are proportional. And then next, on the previous slide, the next thing we did was we cross-multiplied, because when we have equal fractions, we can always cross-multiply. So if I cross-multiply here, that gives me a squared. If I cross-multiply the other direction, x times c, xc. If I do the same thing here, b times b is b squared, and y times c is yc. And the reason I got that was because I cross-multiplied. Now what do we do? All right, now what it wants us to do is it wants us to add those. So if I add a squared plus b squared, then I would have to add what they were equal to. So I added xc plus yc. And then I noticed that both of these have a factor of c. So I can use the distributive property to take the c out. So that gives me c equals x plus y. So I go to statement 7. Statement 7 says, I'm going to add them together. So I'm going to say a squared plus b squared, because I'm adding my left sides of each equation. And that's going to equal xc plus yc. And all I've done is combine my two equations by addition. And then finally, I can make this a little simpler by using the distributive property to take the c out. So I would say a squared plus b squared equals c times x plus y. And my reason would be the distributive property. And then finally, if I go back and look at the picture, x plus y is the length of the hypotenuse. Another name for it was c. So I could go and substitute in. So my final step would be a squared plus b squared equals c times c. And that would be substitution. And we know that c times c equals c squared. So my final step, a squared plus b squared equals c squared, which is what we wanted to prove. Got that by multiplying c times c. So we started with the given, which is a right triangle, and we ended with what we wanted to prove, which was a squared plus b squared equals c squared, and that's the Pythagorean theorem.